Hi everybody. Today we'll discuss another problem from a binary search series, which is nothing but find minimum in rotated sorted array. Right. First of all, what is rotated sorted array? So let's say I have this array. This is nothing but this example. All right. I have this particular array, and here I'm rotating it for 4 times. Let's say rotating means pushing each element 4 times. Okay, so if I push one here, one, two, three, and four. So as you can see, if I push one 4 times, basically I'm rotating this array 4 times, so it will come here. Similarly, I'll push two, it will come here. Now, if I talk about six, where will six go? There is nothing ahead, right? There is nothing ahead, so it will start from again. One, two, three, four. So it will come here, which is nothing but at third index, right? So this that is the concept of rotated sorted array. Okay, it itself is another set of problem that you can learn more about. Okay, let me just close this AI feature. It's quite disturbing, but now it's now here we need to find the minimum in rotated sorted array, right? So first thing is by doing just minimum of nums, okay, but if you are going in an interview, this can be one solution, but this is not the only solution that you would like to show to the interviewer, okay, because you want to show off your skill set. So now how we can do it with the help of binary search, basically. Okay, whenever I want to find the minimum, what I can do is I'll follow the same concept of left, right, mid. Okay, and I'll observe where is my mid currently. Okay, so here in this example, both of these example are good to uh, understand some edge cases. Okay, that's why I've taken this example. Credit to Striver, of course. Okay? There is nothing I'm telling. I have made it myself. This is the condensed knowledge that I'm passing on to you. 7, 8, 1, 2, 3, 4, 5. Here the mid will be 2. Okay, that is the middle element. Left, right will be on 7 and 5 respectively. Now, what is the sorted part? Can you tell me? This is the sorted part, right? This is the sorted part. But how we will know which part is sorted, left or right? So if the mid is less than the right, then right part is sorted. Okay, if 2 is less than 5, which is in this case, this particular part is sorted, correct? And or else if it could be maybe 2 3 1 3 1. Okay, in this case mid is 3, and if you observe, right is not less than 3. Okay, which means this right hand side is not sorted, so in that case the opposite end will be sorted. Okay, so this is both the cases, either left or right will be sorted. So here in this case the right hand side is sorted. Now if right hand side is sorted, okay, what is the right hand side from mid to whatever index of right is? Okay, the selected part. In that case, if it is sorted, then the a of mid will be the minimum, correct? A of mid will be the minimum. That's why I'll maintain a variable which will say a of mid, or nums of mid will be the minimum, that is 2 in this case, so 2 will be the minimum. Fine. Now if you observe carefully, even though it is sorted, This is not the minimum element. Correct. Minimum element is available on the other sorted half. Okay. Or other not sorted half. Okay, in this case. That's why it's important to search for the next half in the next half as well. Okay. Whatever it might be. Here from 2 to 5, as we know it is sorted, we know that 2 is the smallest element. 2 will be the smallest element because any number higher on the right hand side of 2 will be higher obviously. Correct. So there is no need to search again in that particular part. So let's forget about it. And currently min is 2. Okay. And we have forget about this one. Right is 1, left is 7 or 0. Okay. 0 to mid is 8. We'll see what is sorted. This particular part is sorted in this case because this part is not sorted. It means the left hand part is sorted. And in the left hand part, if it is sorted, then A of left or nums of left will be the minimum. Correct? Because the mid will be the highest in that particular sorted array. Here 7, 8, 8 is mid. But it is highest. E of left or nums of left will be the smallest. So I'll compare my current minimum 2 is smallest or this nums of left is smallest. Okay. And keep whatever is suitable. So here in this case 2 is still suitable for us, so I'll go with it. Now as we know that okay, we have uh, we are done with the left part, so I'll remove it. Now mid, left, right, everything is at this particular pace. And if I compare, the mid is 1, which is nothing but our minimum. Okay, this itself is a sorted array. Correct. So it is minimum. I'll compare which is more smaller, 2 or the one I found right now. So obviously with the one I found right now, and that will be the answer. Okay, I hope you got a clear understanding of this dry run. Now if I talk about this one, okay, uh, here I have taken this example. Let's see. Here in this case, the one is the mid element actually, and 1, 2, 3 is the sorted means right hand part is sorted. In this time, we understood that the minimum element is present in the sorted array itself. Okay, so still we will go to check on the other side. Why? Because the first example I explained to you. Okay, that was the reason I chose the first example, because it is important to understand that not every time the sorted array will contain the minimum. Okay, even though it is sorted, it might be possible on the other half you get the minimum one, right? So that's the entire working. Now let's start with it. Minimum mini is equal to float of infinity. There is nothing such as a maximum int in Python, so I'm taking a float of infinity for now. Okay. Left will be 0, left right right g ht 0 comma length of nums minus 1. Right? Great. I start again by left less than equal to right. Mid equal to left plus right. 2. This is the mid that we have got. If let's check which is the sorted half. If nums of mid is less than equal to nums of right, then the right part is sorted basically. In that case, I'll take mini as minimum of mid or nums of mid, because again, if right half is sorted, the mid will be the lowest one. Else, min will be equal to mini comma numbers of low, because we are always going for the right sorted part. Now, if the sorted part is solved, okay, in that case, we'll forget about it. How can we forget? Is nothing but right will be equal to mid minus one. So for computers, that's that's how easy is for them to forget things. Okay, you cannot forget like heartbreaks. Okay, let's get back to DSA. Right equal to mid minus one. In this case, the right half is sorted. Fine. So we'll move the left mid plus one. Turn in. Okay. I hope this works. Okay. Let's see. Oops, I gave long naming. Okay, it has passed two basic test cases. Now let's move ahead. Okay, yes, it has passed each and every test cases. So that was the solution for this one. I hope you uh, learned how to solve and what is the approach thoroughly.